Okay. So in that scenario, we want to come up with how many total possible outcomes could come about the entire scenario taking place. So we have flip a dime and then flip a quarter. Flip a dime and then flip a quarter. So there's actually two events that need to happen. And our job is to determine in total how many different outcomes can we get. So what's one outcome? We're flipping a dime and then flipping a quarter. We can get a heads on the dime and then a heads on the quarter, right? So heads, heads. What's another option? Tails, tails. Any more? Okay. Right, so assume that is 4 possibilities. Okay. All right, then 2 more scenarios, and then I'm going to assign you one of them to determine the number of possibilities. You need to write both down. Okay, the second scenario is a choice of chicken, fish, or beef for the main dish, and a choice of cake or pudding for dessert. Okay, a choice of chicken, fish, or beef for the main dish, and a choice of cake or pudding for dessert. Don't do the problem yet. Skip 3 lines and write down our third scenario. And then I will find you one of them to do. So skip 3 lines and write down this one. A choice of either green or blue shirt. A choice of either green or blue shirt. And a choice of blue, black, or khaki pants. Okay, so just like the scenarios from flip a dime and flip a quarter, both of those have to take place, and we're looking for the total number of combinations we can create. So, this row, I'd like you to figure out all the outcomes that come out of the event of number 2. You guys do number 3. You guys do number 2. You guys do number 3, number 2, number 3, number 2. You're going to talk to your neighbor that's in your row if you need to. Work together. And I do not want a listing like we did on number 1. Okay, everyone listening? We're not listing like we did on number 1. I want you to come up with a way to display graphically how we can figure out the number of combinations. The number 1, all we did was listed it. That's not what I want this time. I want you to come up with a display that graphically represents and shows how many combinations are possible. Does that make sense? Okay, you may talk to the people in your row because they're in the same group, but not to the neighbors in the other rows. Okay? Go ahead and do your sign 2, 3, 2, 3, 2, 3, 2. Okay? You're on 2. Yeah, as long as they're in your row. You're trying to find out how many total outcomes can be created, but you're not listing them. You're showing graphically. You're giving me a diagram. Come up with a way to draw how you can find all the different outcomes. But, yeah, as long as it's not just listing. I want a graphic way to show how you come up with all the outcomes. Okay, your job is to find out, to create a graphical representation. So you're just listing them. How can you show it graphically that will display all the different results? Sure. There's your graph. Or your graphic. Okay, but if someone who's on group 2 that thinks that they have a graphical way to show options in 2. Okay? We do it in the space provided in 2 and do it on the left side in case someone has a different approach. You still have some room. Yeah, that's really good. And then take a walk up the places. And explain to us what you're doing, Christian. Hey, Lana. Yeah. So he's doing a row and column thing. How many options did you get? Great, thank you. So you just leave it right there. Okay, so each column had an option of meat. Each row had an option of dessert. And then if you just fill in, connect your row and columns, you got 6 options. People group 2 arranged it differently. Okay, Jeff, can you come up and pick a new color and show it below number 2? If you go up to the top where there's the lines, you can pick the skinny line. Up to the very top, to the right. See those 3 lines, horizontal lines? Yeah. Click that, and then the thickness, get the skinny one. Otherwise, it's really big. Yeah. So what's his method? He just connects the branches, yeah? Thank you. Okay. Great. Those are 2 completely different ways, but then he also gets 6. Does he have 6 lines? Yeah. Okay, group 3, a choice of either gray or blue shirt and a choice of blue, black, or khaki pants. Here's a graphical representation for number 3. That shows the number of combos. Okay, I see some of the same graphical representations. I'm looking for one in particular. Yours. Maybe I show yours up. Number 3, Desmond. How's she doing hers? Well, she's similar to what Jeff did, right? But she's starting with the first choice and then extending branches out of the first choice. Do you know what that diagram is called that she's doing? Well, it has branches. A tree. Thank you, Desmond. This is called a tree diagram. Tree diagram can be horizontally, that she did. We're also doing vertically. No. Tardy. Yes. Okay. So, number 3, how many different outcomes are there when you have first a choice of gray or blue shirt, and then secondly a choice of blue, black, or khaki pants? Yeah, 6, because she had 6 branches at the end. Okay. So, underneath all that, we're going to do a table. Let's see if you can come up with mathematical formula for a fundamental counting principle. Each time we have multiple events, we have a decision that has to be made. And then we have the number of outcomes. Yep, right this. Okay? With the first coin one, we put that dime into this first, and then put the quarter. With the dime, what possible outcomes could show up? Heads or tails. So that's 2 possible decisions. So either heads or tails. What about when we put the quarter? Heads or tails? 2. Okay. And then we said, and then we listed them, we got 4 total outcomes. So number of outcomes for now is 4. Then the next scenario, we have our choice of chicken, fish, or beef. So how many choices do we have there? No, of the meat. 3 decisions there. And then our choice of dessert, how many choices for dessert? 2. And in total we had how many? 6. So first choice we had 3 choices. Then we had 2 choices, which came out of 6. Okay, with our shirts, we have a choice of 2 colors of shirts, and then 3 colors of pants, and we still got 6 outcomes. So you see a connection from the columns. 2 and 2 make 4. 3 and 2 make 6. 2 and 3 make 6. What do we do with these numbers and the decisions? Multiply, exactly. Fundamental counting principle, all you have to do is multiply the number of decisions of the first event times the number of decisions of the second event. We have a betterment, we times by the number of basal students. Okay, now, I'm going to pass out a packet. Here, the first page has some more fundamental accounting principles. We'll probably just do one of them. And I'll pass out a stapler. You can staple the paper you've done to this yellow packet. Here's a stapler for you guys. Then what you just did to this packet. Okay, take a stapler and pass it back. Take the formal definition. Oops, this is the homework, not the notes. Let me get the correct one out. Okay. Now, your printed copy is better than when the computer prints it into the smartphone. So, you can probably read better on the yellow packet. The definition of fundamental accounting principle is used to determine the total number of choices when combining groups of items. You can choose one item from a group of n choices and another from a group of n choices, and then you just multiply those, n times n. Okay? So, let's look at just the bottom example. You are taking a multiple choice test that has 6 questions. And for each question, there are 3 answer choices. 6 questions, 3 answer choices. With one correct answer per question. If you select one of these choices for each question and leave nothing blank, how many ways can you answer the questions? So question number 1, how many choices do you have to fill in for question number 1? There are 6, oh yes, you are right, 3. There are 6 questions. And then question number 2, you only have 2 choices now for question number 2? No. We have 3 each time. And we have 6 of those, which is why it shows that you multiply and we get 720. Yeah, 729, you're right. Okay, if you flip it over, there's a blank side. We're going to talk about the number of outfits you can create in your closet. Does everyone have a calculator? If you don't, grab a calculator. Because it's a lot. Okay, Brianna, give us an estimate of how many shirts you have. Okay. Okay, Brianna, put some notes in here. Jasmine, how many pairs of pants do you think you have? Just an estimate. Just pants that you wear on a normal day, like not pajamas. Oh man. Okay. That's more pants than I have. Okay. Stetson, how many pairs of socks do you think you have? That without holes, right? Because you don't wear the hole ones, hopefully. Good pairs of socks. How many good pairs of socks? Oh man. You guys have a lot of socks too. I calculated my habit. It's bad with how big this is going to be. Okay? What about how many pairs of shoes you have? We're going to take a boy on this one. I really have a lot of shoes. Like my mother's over 30. Omar? 2. She's sensible. I'm like, yeah, I have 6 that are over 30 pairs of shoes. Okay? Then let's say you have 3 belts. And then, if you're a guy, you have hats. If you're a girl, you have some accessorizing scarves. How many of those should we have? 10 and 10, okay. Here's 10 cars, here's 10 minutes, so we're going to go to number 10. Okay, so, if we didn't care that an outfit actually matched, okay? If we didn't care that an outfit actually matched, how many different combinations of outfits can we make? If we just switch one item, it would be a new outfit. How do you do it? Oh, what's there? These little pieces. Just put those bigger pieces in and probably better. So, be nice people. Okay, how do we do this? How do we figure this out? Yeah? Times 30, take your calculator, times 20, times 50, times 2, times 3, times 10. Oh, a calculator can handle it, thank goodness. I thought I was going to go on scientific notation. And you got to calculate that scientific notation, because either the number is too small or too big. Yeah, the blank side of your page. Okay, how many different outfits can we create, Miriam? And how many zeros? Okay, and you can tell me how to say this number. Yeah, because every two is a comma. 1,800,000 different outfits. Just from your 30 shirts and 20 pants. And then a few accessories. This is a different pair. One's dirty, one's clean. It's a different item, which makes a different outfit. I actually have 2 pairs of these black shoes, and this is funny. They're very similar. A lot of different kinds. One's older, one's dirty. These are the new ones. And I went on this trip this weekend, a backpacking trip, remember I was gone? And I quickly grabbed some shoes for the road. Well, halfway down there, I took my shoes off in the car and looked, and the insoles were different. So I grabbed one from the new pair and one from the old pair. So they're both black. They're almost exactly the same material, but the bow here is pointed and the other one has a blunt edge. So I had mismatched shoes for my whole trip in the car. But they're nearly the same, but they're actually different shoes. Okay, now let's talk about your combinations and your lockers, your locker combos. How many students are approximately at Cottonwood High? Yeah, about 1,500, something like that. Let's do that be nice number real quick. Assuming everyone actually used and had a hall locker and a gym locker. That would make 3,000 locker combinations, right? Assuming we have exactly one per student and no more or less. Well, I do think it's possible that 2 lockers in the school could have the same locker combination. You think it's possible? 3,000 is a lot of lockers, right? Well, how many digits do you have that you could spin to on the first spin? I think it's 0 through 49, which makes 50 because of the 0. Now what we're going to do is 2 different ways. The first way is going to be with replacement. With replacement says we're allowed to repeat numbers. So on our first spin, we have a choice of 50. Now, on the second spin, assuming we're allowed to repeat numbers, which generally in locker combinations you're not allowed to, but we'll do that one later. And on the second spin, we can repeat how many options can we spin to on the second spin? 50. And on the third spin, 50. And it's just 3 spins, right? Okay. So, how many different locker combinations can we create out of just 50 numbers using 3 spins? You need a calculator. Calculator's up here. Come on. Ryan, do you need a calculator? Come get a calculator. Oh, you can stand up and come get it. It'll be good for you to stand up. Come get it. Right, come on. All right, come get a calculator, please. Can you hold on to the calculator? Come get one. Can you have one back there? Yeah, AJ, do you have a calculator? Can you pull it out, please? It's right there. Oh, you can grab a calculator. Grab a calculator. Okay. How many different locker combos with your customer did you get for us? Yeah, 125,000 different combos. Okay. Now, we're going to do the same idea but without replacement. So once we use the number, we cannot use it again. Without replacement. On the first spin, how many numbers can you spin to? 43? No. 50 on your first spin. Now, if we're not allowed to repeat, we can no longer use that number. So on our second spin, how many numbers can we spin to? 29. And then on our third spin, 48. Now let's see how many different combos. It should be less, actually, because you have less options. Stetson, what'd you get? Good. So without replacement, it should be less because you're taking away some options. But now do you think we probably have two locker combos in the school that are exactly the same? It's possible. We only have about 3,000 lockers. So if we're able to make 117,600, probably a good chance we don't have some duplicates. Okay, that's one little cutting principle. Does that make sense? Mm-hmm. 50 to the third power. Yep, exactly. Okay, now on the next page, we're going to use the skills. Last call, does anyone bring skills? Okay. Yep. So I'm going to be on some way with cut up pieces of paper, but you need to make it green for the green skill. I'm just going to do it this way. Now, if you wanted to use skills, you should have brought them. As I told you. Okay, so while I'm setting this up, you're going to stand up and take a quick break inside the classroom. Ryan, we're going to drink quickly. If you're quick. Be quiet in the hallway, please. Like this one, we bring the decimal in all the way into a one non-zero digit. So we 1.25 drop off the zeros, and I have 1, 2, 3, 4, 5 jumps. So we 10 to the positive 5. So this is a big number. If I had moved it this way, a small number, this would be 8.2 times 10 to the 1, 2, 3, 4. Again, I did 5 jumps, but since it's a small number, it's negative. So you go in the opposite direction. Okay. These will be our fake skills. Okay, we're going to recruit them back in. Okay, and now find your vector C. And well, you need to, on your way to C, you need to be in a pair of 2. I think we have 22 in here, so it should be an even number. The cell phones we put away now. Okay? One of your neighbors right next to you, either in your row or the row right next to you, not across the room. We need to get in a pair of 2s. So, pick a neighbor right next to you to be your partner. Can you open that door, please? Open it up, Brian. Get in a row right next to you. Pair of 2s. Okay, would you get your desks together so I can see the pairs? Pairs of 2. Yep, there's someone right next to you. Now, if you can send one person to come up here and get a part of your peak skills. I got your hand. Brian, you have a partner? Hey, any other groups? You have a partner? Guys, you have a partner? You have a partner? Just all in person? You have a partner? I thought we had even, so. Christian, you have a partner? Okay, you can have that. I wouldn't recommend eating it. It's been on the floor for a whole day. Okay. AJ, do you have a partner? Okay, why don't you just scoot over with these girls? I'll give you one. Yeah. No, you can get Jeff. Jeff will scoot over with these girls, and I'll give you another stack. Oh, there's 2 of you? Okay. One of you be partners with Jasmine. Okay, Tyler? Okay. Oh. So that's a mutual partner. Okay. Already has papers. Okay. So, your papers, your strips of papers, represent the different colors of Skittles. How many different colors of Skittles are there? 5. What are those colors? I don't think it was blue, was it? Green, probably. Oh, there's 2 greens. I messed that up then. What color are we messing then? It's orange, huh? I did another green. No, that is red. Oh, man. Did you not get pink? Okay. So our pink's going to be a red. Okay, I'll make it red. Put it down and make it red. Yesterday I accidentally colored blue instead. There's not a blue Skittle, so I messed that up yesterday too. Yeah, I guess I have the chocolate pack, but not in the regular pack. Oh, interesting. Okay, that's Skittle time. Anything we're doing with Skittle symbol. Okay, throw away one of your greens. We don't need that. Do it just in one day. There you go. Okay, excuse me. Can you just scoot your desk? Thank you. There's a table over here. Who are you? Oh, Robin. We'll just throw away. Really. Just hold on to it. Okay. You guys can shoot us together. Okay, does everyone now have, so the red ones, we have 5? Okay, on your packet, would you please turn to permutations? I'm going to be using specific vocabulary because permutations is very similar to the next place. Combinations, but there's a slight difference. So please look through the vocabulary and follow along. With your pencil, would you write down the first letter of each color? So let's see something up. We have a purple, green, what are the other colors? Red, and yellow. Okay? Now, the permutations, please listen. Order matters. We are looking for, I'm going to use the presidency as the, sorry, can't spell right at the same time sometimes. Presidency, because it starts with a P just like permutation. Sorry. Turn it off. Okay, presidency starts with a P just like permutation starts with a P. In a presidency or permutation, everyone has a position. So you have those P's, presidency, position, permutation. We have a president. Who's the president of the United States right now? Barack Obama. And who's the vice president? It's definitely not a woman. Joe Biden. Good job. Who's the Secretary of State? Arnold Schwarzenegger now. I don't actually know who the Secretary of State is. And then we have a Speaker of the House, and then we have someone in the Senate. Okay? So there are 5 positions in the presidency for the permutation. Okay? If we just switch 2 people, please listen, if Joe Biden was president and Barack Obama was vice president, would that be the same presidency or a different presidency? It would be different. It would be different. So in the presidency, the order of the positions matters. So let's do our 5 big skills. You're going to make as many orders as possible. Here's one order of our presidency of Skittles. You good? You're watching? Purple is the president. Green is vice president. The red is Secretary of State. Orange, House of Representatives. White is the House, and Y is in the Senate. So if I just rearrange the G and the P, everything else stays the same. That is a new presidency. And maybe I just rearrange the R and the P this time. That is another new presidency. So I want you to go through and make a listing of all possible presidencies of Skittles. Play with your partner, you can do it with the tiles. And then try to find a pattern about you rearranging them so you don't miss any. And in 2 grades, you don't need both things. Just set the other thing aside. Because I messed up. Yeah, because Y is president. Okay, make a list of all of them. You should be listing all the different presidencies. Be careful not to miss any. There's more than 3. So list some more. There's more than that. Listen to this. You're going to listen to 1. You're going to listen to 1. Your assignment is to list all of them. Oh. Yeah, actually, well, you guys them up here because we need to use this line for something else. Should we all run down? Nope. There's one that. Okay, I'll give you a break. There's a lot more than you ever want for this. So, this is why I asked you on the last page to do it without listing, to create a diagram. Because sometimes listing gets a little out of control. There's too many to listen. You would take a very long time. You can easily miss one. So let's talk about the math. At the beginning, how many options are there for president? 5. And once the president is chosen, how many options are there for vice president? 4. Because the president's already been chosen. And, AJ, what's the options now for Secretary of State? And then the reason I have and, so I hope you're writing the and then 1. How did you get that number? What did you do? Times. This is a fundamental counting principle. 5 times 4 times, it's actually not a fundamental counting principle, it's very similar. 5 times 4 times 3 times 2 times 1. Now actually, this shorthand is called 5 factorial. See this exclamation point? It means factorial. It's a shorthand because what if we were supposed to do 100 times 99 times 98 times 97 times 96 plus 2, all the way down to times 3 times 2 times 1. You must write that out by hand. No one does. That's why I have a shorthand called the factorial. So factorial means we start with this number, in this case 5, and multiply all the way down to 1, descending as you go. Okay? Now we get 120 arrangements of presidencies. So we write this down. No? Now, in statistics, and notice I wrote the word and between all of those numbers, what do we do between all those numbers? We multiply. And means multiply, or means something else. Or means add. So look for those words over in statistics. Can you put the calculator down, please? Can you put the calculator down, please? And means multiply, or means add. So be aware of those two different words when you do something different. Okay, now, number 2, how many different ways can you line 3 of your schools up? You still have 5 to choose from at the beginning. How many different ways can you arrange them into a presidency? You have 3. The first choice, you have 5 skittles, right? The president. And the vice president, how many choices of skittles do you have? 4. And then for Speaker of the House, how many? Or I guess, hold on the next one. Secretary of State, you have 3. So is this 5 factorial? No, 5 factorial goes all the way down to 1. So this is just 5 times 4, which is 20, times 3, which is how many arrangements? 60 arrangements. Okay, so we're going to change CRT to Sage. Sage review quiz. How many different ways could you arrange 4 questions from the 9 topics? Okay, there are 9 topics listed. So we only have time to review 4 of them. So how many different ways, when we care about the order at which we review them, could we review 4 topics? How would you figure that out? Yeah. Wait. You said 9 because you still have 9 choices. And then you go there? 8. But how many questions do we actually How many times do we do? Only 4. So we stop at 6. Can you multiply that? This is 9 and 8 and 7 and 6. So how many different arrangements for our review, given that we have 9 topics, we only have time to review 4, and we care about the order. How many? 3,024. 24 arrangements for our review quiz. Okay? Now, logically, there is a formula, and there's a way for your calculator to do this for you. And it's N permit R. There's a feature of programming programs into your calculator. If you don't need calculators yet, AJ, you should put that down. Please. Get your pencil and catch up. N stands for the number of total objects. Number of total objects. R stands for your group size. Yeah, group size would be okay. Okay. Now, the formula is n factorial over n minus r factorial. The difference of n minus r factorial. Occasionally, you have to work this out by hand, but generally, you're able to just plug into your calculator. So we're just going to do a couple of workouts by hand so you know how it works. In our review for stage test example, how many different topics were there that we could review? 9. So we're going to have a 9 permit. How many topics do we have time to review? 4. 9 permit 4. Okay, so on the top goes n factorial. What goes on the top for n? 9 factorial. Good. Factorial. 9 minus 4 in the denominator. Okay, who can tell me what 9 factorial is? Simpson? That's 9 factorial. What's 9 factorial? Stand it up. Yep, all the way down to 1. This is why we have that shorthand for factorial, because the bigger this number gets, the longer string you have to write. And 9 minus 4 factorial, is what is 9 minus 4? 5. So can you tell me an idea what 5 factorial would be? So, yeah, 54,321 times between all of them. Oh, look, if you use any times, you can cancel. 1 cancel, 2 cancels, 3 cancel, 4 cancels, 5 cancels. And we're left with, are we left with this? That's right here. 9 times 8 times 7 times 6. Okay? Which then gives us 3,024 arrangements. Now I'm going to show you how to do it on your calculator. Okay, so once again, everyone needs calculators. Laura, open the calculator, please. Okay, first you actually have to type in the 9. Right, let's do that, please. Okay. So, turn on calculating some stuff. First you have to type in the 9. We want 9 permit 4. So I hope everyone's doing this with me. You need to go to the math button. The math button is right below the green button. Right below the green button, and then it takes you to this screen. You see where it says probability? Or an abbreviation for probability. Right here, PRB, right? So you have the arrow to the right to PRB. Now look at the choices. Ooh, look at that exclamation point. What is that? factorial math, right? Which one, though, do we want that is for our permutation or presency? Number 2, see NPR? So we said number 2. So now it says 9 permit. How many do we want in our group? 4 in our presency. Okay, and did we get the same answer we got before at the bottom? Yeah, 3024. That's a quick way to do it with your calculator. Okay? Now we're going to learn about a different one. We're going over to the combination side. Here we still have 3 colors. To start with, purple, red, orange, green, and yellow to start with. But a combination is different than a permutation. A permutation is a presency where we care about the order. Everyone has a position. See how all those words start with a P? Presency, position, permutation. Well, combination order doesn't matter. It's just a group. It's a collection or a committee, a handful. It's just a committee. On a committee, it's just a bunch of people working together. So we reach into the bag and grab a handful of Skittles out of one handful. By just changing which Skittle got into our hand first, which Skittle got into our hand last, that doesn't matter. We don't care about the order that we grab them. We just want a handful or a collection or a committee. Okay, so our first example, this is what you can actually do. With your 5 tiles, you have 5 different Skittles to choose from. How many ways can you choose 3 of the Skittles to be in a committee? What's one committee that could happen? Okay, wait, I don't know person. What do you have, Mom? What's your committee? I need 3 colors. Okay, orange, red, and green. Now, what if I switched red and orange? Would this be a different committee, red, orange, green? Would that be a different committee? Where we don't care about order? No, this is a repeat committee. It's the same handful of Skittles. Okay, so we don't want repeats. What I think a new committee would be to change to a completely new color that we haven't used yet, like the purple. That is a new committee. So on your paper, I want you to list and don't repeat any. Once you write 3 letters, just switching the order doesn't make that a new committee. That would be a repeat. So you have to have 3 completely new colors that haven't been collected together as a committee yet. So I'm trying to figure out how many different committees can you make. And this one's actually manageable. How many different committees of Skittles can you make when you don't care about the order? You have 5 to choose from at the beginning. I'm going to flip over to the combinations. So this is where we're at. It's too many. All of the 5 Skittle colors has less than 15. Nope. You can do it with a piece of the paper that helps you visualize. Okay, who knows we found them all? How many up? 8? Anyone found more than 8? 10? You want more than 10? Okay. Good. Turns out, sorry. Okay, it turns out they're exactly 10. So good job, Brian. Hopefully you wrote down all of them that weird. They're exactly 10. Okay? Let's figure out the math for this. This formula is not a P, not permit, it's choose. The formula is N, choose R. Again, N stands for the number of total choices, and R stands for the group size. This formula is a little different though. So if we don't care about the order, they're going to be less. It's very similar with the n factorial on the top and n minus r factorial on the bottom, but the denominator we also divide by an r factorial. That's the formula. No, someone's already out. Okay? So if we were to write this out by hand, what would my n be? How many schools do you have to choose from? 5. We have 5 different colors. We're choosing how many in our group. Okay. 5, choose 3. Okay, Jeff? What would I write on the numerator? Let me actually write this a little higher. 5, choose 3. 5 what? What's that name? Factorial. Okay, in the denominator we have r factorial. Now what is r? Which is, in this case, 3. Factorial. And then we subtract them. 5 minus 3 factorial. Okay, so if we work this out, 5 factorial. Okay, Haley, can you tell me what 5 factorial would be if we expand it out? So 5,454, we need times, thank you, between all of them. And r factorial was 3 factorial. The bar was 3 factorial. Good. And then times by the factorial of 5 minus 3. 5 minus 3 is just 2. So it's 2 factorial, so 2 times 1. So I look for my highest number in the denominator. What's the highest number in the denominator? The 5. That is not 5, I lied. In the denominator, what's the highest number? 3, so start there. 3's cancel, 2's cancel, 1's cancel. Leaving behind 5 times 4, which is 20. And in the denominator we have 2 times 1, which is 2. All of that equals 10 combos. We didn't call it arrangement this time. It's a combo, a collection, or a committee. Okay? Try with your calculator. How do you think we type this into a calculator? Math that was right there. How do you type this into a calculator? You have to type something in first. Type number 5. Type number 5. The math, which is underneath the green. So right over to probability. And you see the NPR and NCR? We're doing combination with the C version. And when you do 5, choose 3, did you get 10? Yes. Okay, we're going to do the same example again and see how it changes when we don't care about order. Same example as before, bear in mind, topics to study, we're trying to study 4 of them. So how many different ways, not caring which order we review them in, how many different ways can we review these? So with our setup for the formula, what's the n? choose. How many do we have? 4. Again by hand. What goes in the numerator? Right, so 9 factorial, which only said it would be 9 times 8 times 7 times 6 times 5 times 3 times 2 times 1. And in the denominator, what's r factorial? Okay, 4 factorial, which expands to 4 times 3 times 2 times 1, times by the difference, n minus r, or 9 minus 4, which is 5 factorial. So times by 5 factorial, which is 5 times 4 times 3 times 2 times 1. What's the highest number in the denominator? 5. Good. So I'm going to start there. I look for the highest because then I have a nice little pattern that always cancels straight out. Ooh! The numerator sure looks familiar. 9 times 8 times 7 times 6. When have we seen that before? An R? These are all R's. Okay, what have we seen 9 times 8 times 7 times 6 before? On the other side is the same problem when we cared about order. We did the same problem, we cared about order. We got 9 times 8 times 7 times 6. Now combo, we don't care about order, so there's not as many options because we have to divide by the r factorial. When we divide by something, we make it smaller. When we divide by a whole number, we make it smaller. So 9 times 8 times 7 times 6, we already did that. That's 3,024. Without a calculator, what's 4 times 3? 12 times 2 times 1, 24. Now with a calculator, divide those and see how many different combinations we can create, yeah? 126 combos. Well, we don't care about order. It's just we reach into the bag and grab a handful of 4 review questions. Now let's just practice one last time with a calculator. Make sure we know how to do this. Okay, we're almost done. 9, choose 4. How do I type that in? Everyone should be practicing this. This should be a super easy question on the SAGE test. If you know how to use your calculator. 9, where's the choose button? Math, underneath the green. Math. Probability over here to the right. And what I'm doing is C, the committee, and then 4. Now on your homework, 126, that's great. On your homework, you'll be given a scenario, and you have to decide, is this a fundamental theorem or a fundamental counting principle? Or are we carrying about order as a presidency permutation? Or is it just a committee combination? They're so similar, but yet so different. Okay? One last thing on the back side, just to practice setup. And you can probably see it better on your paper than how it just prints to smart. I don't know why smart decreases the quality so bad. Aria, could you read that example starting with Mr. on number 4? Logarithms, you'll learn those next year. Okay, keep going. Great. Okay, so just to practice the notation one last time, permutation versus combination. Permutation is the P. I say the word permit, so I keep with the P in the notation. What do I write here on the left side of the P? The N? What's the N? How many are there? To choose from. How many are there to choose from? 5. 5 permit. How many in our review session? 3, when we care about order. So type that in your calculator really quick. 5 permit 3. 5, and you go to math. Make sure you select the NPR. 60. 60 arrangements or presencies. Which says down below, if we didn't care about the order, we just wanted the group to review, it would be 5, choose 3. You practice that with your calculator, please. 5, choose 3. 5, then you go to math, go to probability, which one's to choose? Number 3. And then type in 3 again, 5, choose 3. How many did you get? Great. 10, this is combos. Use the arrangements word for the presencies or permutation and combos for our collection or the committee for the combination. Okay. Great. Good job, guys. I'm going to give you a worksheet, and we're going to look at a couple of them on the back so we can decide, are they combinations, are they permutations, or are they fundamental counting principles? You can throw your fake Skittles away. Probably don't eat your fake Skittles. Not good. It's stuck in your braces. Okay. Open up your pink homework packet. We're going to do a couple of them. So, 3 homework problems being done right now. The other ones, the room groups that has them, then we'll receive a packet. So, we only page that says this, permutations and combinations worksheet. The first page is about fundamental counting principle, I believe. And then we'll start permutations. Numbers 1 through 6 says you must show the setup. So that means showing the work by hand. This is a 7. Showing the setup would be showing 7 factorial over 7 minus 3 factorial. After you show that setup, then you can use your calculator. Okay, but once the setup, so then you can use your calculator. Number 7, again it says show the setup. The ski club with 10 members is to choose 3 officers, captain, co-captain, and secretary. How many ways can these be filled? What type of a problem is this? Okay, the ski club with 10 members is to choose 3 officers, a captain, a co-captain, and a secretary. On this page, on the flat list, you have 2 options, permutation or combination. Let's vote. Who thinks it's a permutation? Okay, who thinks it's a combination? Yeah, I was just being an example. Okay, some people didn't vote. Who can argue their case? So voted. Aria? The officers have a position, right? They care about order. So it was a permutation. So to solve the problem, we would write how many people are there to choose from for the positions. Well, I need your bag on the ground, please, and you need to be doing this with us. There's not 3, there's only 3 officers, but 10 permit because we're caring about their presidency or their position. Permit 3, and then the setup would be 10 factorial over the difference, 10 minus 3 factorial. After you write that out by hand, then you can use your calculator. Then you can just do the 10p3. 10 permit, go to that math. I hope you're comfortable now going to that. Permit 3. How many different ways Given 10 members, can we create a presidency of 3? Yeah? Good. 720. 720 arrangements. Okay, let's look at number 9. For a segment of a radio show, a disc jockey, Dr. Jones, can play 4 songs. If there are 8 to be selected from, in how many ways can the program from the segment be arranged? So we have to decide, do we care about order? Presidency with permutations or a collection of combinations? So let's vote. Who thinks this is a permutation? Who thinks it's a combination? Good. Those who voted, most of them have it. It is a combination. Does it say anything about different positions, playing the first song, second song, third song, fourth song? No. So it's just a collection for a committee. So what number? Choose what number? What's our N? What's our N? 8. We have 8. Choose. How many songs can we play? Oh, sorry. You're right. We're on number 9. Okay, 8. Choose. How many songs can we play? 4. And we need to just do the setup. Now remember, combinations have slightly different setup in the denominator. It's still 8 factorial, and it still has the 8 minus 4 factorial, but what do I also need to put off for my combinations denominator? The r factorial, which is a 4 factorial in the denominator. Okay? Step, please. Every time to write this down. Okay, now type the 8, choose 4 in your calculator. Yeah. So there's 70 different combos that he can play his 4 songs. Okay, from the back. All you have to do on the back, you don't have to work it out. You just have to decide what type of problem it is. From the very back, AJ. From the back. You just have to decide what type of problem it is. And that's just the tricky part. Once you figure out what type of problem it is, it's easier. Number 19. In a race in which 6 automobiles are entered and there are not any ties, in how many ways can the first 4 finishers come in? Okay? Is this a counting principle, a permutation, or a combination? So that? It's a permutation. Because we're the first place, the second place, the third place, or fourth place. So number 19, all you have to do is put a P for permutation. Is it? You have your packet? We're answering questions. 3 points. All you have to do is put a P by number 19. And that's answered. It says no need to solve in the directions. Look at number 20. The model of the car you're thinking of buying is available in 9 different colors. Man, I don't think cars come in 9 different colors anymore. It's like you have a choice of 3, and they're all the same. That like, if I was to buy a brand new car and choose color, I'd go with like a bright color that no one has, because everything's like silver and blue and black and white, right? Yeah, I would choose a color that no one has. Okay, so the model of the car you're thinking of buying is available in 9 different colors, 3 different styles. Hatchback, sedan, or station wagon. Wow, that's old station wagon. And how many ways can you order the car? Good. Why is it better than counting those for, Jeff? Yeah, it's the tree diagram. First you choose your color, then you choose your car, because it's a tree diagram. So by number 20, all you have to do is write CP for counting principle. Okay? So, be very careful when you're choosing. Is a permutation, combination, or counting principle. They're very similar and yet very different. Okay, that y'all just back. Counting principle. Thank you for being great today. If you have those fake skills, please make sure to make it to the garbage can. And I need all calculators with the lids on, put back in order, please. Okay, AJ, can you get this?